Hi, everybody. Thanks for sticking around for the last talk. I know you're all exhausted, so I've got a nice, relaxing one for you that's going to be nothing but walls of code in 4 different programming languages. On the other hand, we're not going to be searching for the meaning of life, the universe, and JSON serialization. We're going to be bending Ruby until it breaks and having some fun with it. I'm Michael Fairley. You can find me on Twitter and GitHub as Michael Fairley. Very clever, I know. I work at 1000 Memories. We help families and groups of friends and organizations collect and digitize old paper photographs, organize them online, and then share them amongst the people who care. We have an iPhone app called Shoebox that is the easiest way to scan old paper photos. You snap a picture of a photo. This is me on my first birthday, I believe. We automatically detect the edges, and then we crop them. And we give you some color correction controls, and you end up with a great-looking picture. And you can get it on the App Store. We have an Android version coming out very soon, so if you're an Android user, stay tuned. I've learned a lot about my family history while my parents have been scanning some of our old family photos on Shoebox. This is my great-grandmother, who I grew up calling Nina, but her real name is actually Ruby. And my great-grandfather, who I grew up calling Papa, his real name is actually Singleton. So, so it's in my blood that I should be a programmer. So extending Ruby with Ruby, what does this mean? Why is this the title of the talk? Well, when we talk about metaprogramming in Ruby, we often think about things like using respond to and send to save ourselves some typing and dry up our code a little bit, or monkey patching a library that doesn't quite do what it should be doing. But metaprogramming in Ruby is actually really powerful, and when combined with some other things like executable class bodies, we can actually bring in features from other programming languages into Ruby, thus extending Ruby with Ruby. So I'm going to take a feature from each of these 3 languages and show you how we can bring it into Ruby. There's some good ideas, some bad ideas, and some absolutely crazy ideas in this talk. So just be warned. So let's get started with Python. Up until about 2 years ago, when I started doing lots of Ruby and Rails development, Python was my primary language. And one of the things I miss most from my Python days is function decorators. Function decorators are some syntactic sugar Python has for helping you mix in common behavior into your methods and functions, in a very similar vein to how we mix modules into our classes to use common functionality. So I'm going to show you what these are, why they're useful, and then how to add it to Ruby. So starting with Ruby, if we were hypothetically running a bank in Ruby, we would want a method like this called sendMoney, where we pass it 2 accounts and the amount to transfer. We subtract the amount from one's balance, add it to the others, and then save it. So there's a couple things wrong with this code, but the most notable of which is the lack of a transaction. So if from.save fails, or if from.save succeeds and to.save fails, we've lost the money into thin air, and our customers are quite unhappy. Active record makes this a simple problem to solve. We throw this transaction block around it, and we're good. Let's look at this in Python now. So the non-transactional version looks nearly identical. I think there's 5 characters that have changed, and they're all symbols. But if we don't use decorators, once we add in transactions, things get very, very ugly. This is exactly what Rich Hickey was talking about yesterday when he was on Monday when he was talking about complecting. We have 10 lines of code in this method. 4 of them are the actual domain logic we're trying to express, and then 6 of them are boilerplate for doing a transaction. This is messy because you are required to remember all 6 of these lines and exactly what to type in every time you want a transaction. And if you screw it up, money is disappearing into thin air, which is not a good failure scenario for your software. What Python does give us, though, is a way to easily pass around and manipulate functions as first-class objects. And we can use that to solve this problem of the ugly code for the transaction. So we take our sendMoney method after it's defined, pass it into a method called Transactional, which is going to wrap the original sendMoney method into a new method that exhibits the transactional behavior. And then we assign that method to send money again. So all future calls to send money are actually going to go to this new transactional version. So what does transactional look like? Well, it might look like this. It takes in a function, send money in our case. It defines a new function. That function has all of the transactional boilerplate that we saw before. Inside of it, it calls the old function, the original send money, and then it returns this new function. So we pass send money into transactional, and we get out a new version of send money that exhibits the transaction. And so function decorators are a little bit of syntax for doing this elegantly, and it looks like this. You put @transactional before the method, and it automatically does. This is translated into that. So you don't have to specify the name send money 3 times. You only specify it once when you're defining the method. And it's also at the top of your code instead of out of sight, out of mind at the bottom. So what? I just showed you that function decorators and blocks can do the same thing. But I think there's a few cases where our usage of blocks in Ruby's falls down. So we have this very naive implementation of Fibonacci. When you want to calculate the Fibonacci of 10, you're going to recalculate the Fibonacci of 5 like 60-something times, which is incredibly slow and inelegant. And the easy way to solve this is by memoizing our results, by caching the result of the computation and then using it whenever we need the value again. So we do this in Ruby by something like this. We initialize this memoization hash if there's not one, and then we fill in the hash with the values of the computation, and we key it off of the arguments to the method. And there's some gotcha cases here. If this method were to return false or nil, those actually pass through or equal. So you need code like this to check to see if the key exists in the hash rather than relying on or equal to solve it for you. And again, we have 2 pieces of functionality in this method. There's the code that evaluates the Fibonacci algorithm, and then there's the code that does memoization. And these 2 things have been complected together. So we could solve it with blocks. We could make a memoized block like this. This is somewhat inelegant, though, because blocks don't know the name of the method that called them or the arguments that it took. So we have to pass those along manually. And if we would also want to time this method and synchronize the access to it, we end up specifying this name fib all over the place, and we end up specifying the argument all over the place. And then whenever we want to rename this method or change the arguments it takes, we now have to remember to change it in 3 or 4 different places. Otherwise, our code won't exhibit the behavior we expect. So there was a solution to this called active support memoizable. This is deprecated as of active support 3.2 and is gone in master. And it was this little thing, you put it after your method, and you call memoize fib, and it undefines fib, wraps it in a new method, and redefines fib. And that sounds a lot like a function decorator, and you're right. It's very similar to this case that Python was forced onto 5 years ago, where you're doing this retranslation after the method. The Python community felt very strongly that this was a bad idea for a couple of reasons. One of them is that if you were to move the method elsewhere, you might forget to bring the code that was after it that actually changes how it works. And now your code is not next to the code that runs with it, and it's kind of awkward. I also think that you should be able to trace the execution of your code from top to bottom. And in this case, the very first piece of code that runs is the very last line on the slide. That's inelegant and hard to debug. So let's look at this Fibonacci example in Python. We have Fibonacci, and we want to memoize it. We put @memoize. We want to time it. We put @time. We want to synchronize it. We put @synchronize. And that's the end of the story. So what we're going to take the next few minutes to do is see how we can do the same thing in Ruby and have it look like this. Notice that the ats have become pluses, and the name of the decorator is capitalized, indicating that it's a class, but otherwise it's the same syntax. So to dive into the code, back to our send money example. We want to make this transactional via a decorator instead of the active record block we had. So what's transactional? Transactional is a subclass of decorator. It has one method, call, and call gets passed to the original method as well as the arguments it's currently getting called with. This is a little different than how Python does it, and we're sort of forced into this because of the way Ruby binds methods to objects. But for the most part, it's functionally equivalent. Inside of call, we run the transaction, and inside of the transaction, we make the original method call. So what is this decorator class up top? What's in there? The answer is not much. A couple class methods. This first one is the unary plus. In the same way that you can do -3 to make a negative number, you can also do +3 just to indicate that it's positive. But those plus and minus are actually class methods on fixed num. And so we can override this with this plus add notation. So when we call plus transactional, this code runs instantiating a new method of transactional and storing it away in this class variable. And then we have methods to get the decorator out and clear it. So there's a little more to the story of the context of where you put the decorator. I've made it so that we have to extend method decorators in a class where we want to use them. You could have directly extended the class itself. I find this to be inelegant because it forces every class in Ruby to use decorators, and I think it's a little rude to users of your library or users of a library that uses your library to force your classes to have behavior you don't expect. So what's in this method decorators class? Well, there's one method, and it's method added. Method added is a hook that the Ruby interpreter calls when a new method is defined. It's a instance method on class, and it's very useful for modifying the behaviors of method like this. So the first thing we want to do is call super, so that other libraries who want to override method added get their chance to run. We get the current decorator if there is one, and we don't do anything and return if there's not one. And then if there is one, we make sure to clear it out so that when we redefine the method in a few lines, we don't re-invoke method added, assuming there's a decorator ending up in an infinite loop. We have to get the original method that was just defined. So we grab it with this instance method and store it away. We start redefining the method. Inside of the method, we have to rebind the... So instance method returns an unbound method, which is a method that doesn't know what object it belongs to. And so when you call bind on it, it tells it what object it should belong to. And then we call the decorator. This is the same call that we just defined in transactional a few minutes ago. I forgot to mention that please feel free to interrupt with questions at any point. I've left some time for questions at the end, but I'd be glad to use those in the middle if anything doesn't make sense. So what else do we need to do to have a production-ready library that is identical to Python's version of decorators? Well, we only supported one decorator, but it'd be easy enough to add a list that the decorators are added onto and then loop over it when we redefine the method. Our decorators do not respect method visibility. When we called define method, it defines a public method. So in this case, the send money method would actually end up being public, which is quite bad. Method added is not called when singleton and class methods are defined. And something I didn't show on the Python that's actually pretty cool is that you can pass arguments to the decorator itself, allowing you to specify some options or parameters that it needs. So we could make a retry decorator that retries the method up to n times if the method throws an error. This would be useful when you're talking to something like the Facebook API that throws an error on a large percentage of requests. I've actually done all this work for you and rolled it into a gem called method decorators. I think you should use it. I think this is something that makes our code cleaner and easier to read and easier to reason about. And if you want to check out the source code or the tests, they're on GitHub as well. The main reason that I've done this is so that we can end the Ruby versus Python debate once and for all. We can bring the features from Python into Ruby, but Pythonistas cannot bring features from Ruby into Python. So next time you're having an argument, you have the trump card, but then you have to make sure to plug your ears and go la 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 when they bring up things like NumPy and first-class functions and whatever else. So let's move on to talking about Scala for a little bit. If you haven't played around with Scala, I would highly recommend it. It is a language that is very similar to Ruby in a lot of ways. It has blocks. The result of every line is an expression, so you can return implicitly from the end of functions and things like that. It has modules and mix-ins. A lot of things we take for granted in Ruby that are pretty rare in other languages. And it's also statically typed, but it makes heavy use of type inference so that you don't actually go around typing button, button equals new button like you do in Java. So it has this thing called partial application, which is a general functional programming technique. But Scala's method of doing it is really elegant and something that I like a lot. So in Ruby, if we wanted to take the numbers 1, 2, and 3 and turn them into a string, we would use some code like this. And of course, you all know that we can use the symbol 2proc version to make that a little shorter. I've always found this to be quite awkward. No newbie to Ruby and Rails has ever looked at this and said, I know exactly what that's doing. I know what ampersand : means. It's just a piece of magic that we've told people, don't worry about it. And it works. If we look at the same thing in Scala, though, we go over the numbers 1, 2, and 3 and map them to a string. This first I is the argument to the anonymous function that's being defined, and the second I is the usage of it. But we can partially apply this function like this. And I think this is incredibly intuitive syntax, that you can look at it and say, Scala is filling in this blank with the argument to the function, and it makes sense. And Scala can also, we can use this technique inside of more complex functions that have some math or some other function calls, and we replace the argument with an underscore. But if we take these same complex blocks in Ruby, there's not a good way to shrink them down to something a little more readable. It is possible, though, to shrink them down to this, which is almost identical to the Scala version, except there's an added ampersand at the beginning. There's a lot of bugs with this, and it also requires that the underscore be the first argument, but be the first thing in the block, which I don't really like. But with a little bit of added ugliness, we can actually make something that is equivalent to Scala's partial application. So you'll notice this is incredibly ugly. I think it's a horrible idea, but it's interesting that we can do this. So I'm going to break the syntax down a little bit just because it's kind of awkward. So we have a block that is what we want to partially apply, and we pass it to a function called underscore. The result of that function underscore has 2proc called on it by the ampersand, and then that results in the block getting evaluated in an interesting concept, an interesting way that we'll show in a minute. So what's the first underscore method that I talked about? It's simply a method defined on object that returns a new partial application. Like I said before, I think sticking methods into base classes is probably a worst practice, and this is bad code, but it's interesting. So what is this partial application that we're building here? So we pass it a block, and it stores that block for future use. When the ampersand results in 2proc getting called on it, we have to return something that's callable. So we define a new lambda that is called each time we want to evaluate this block. And inside of the lambda, we define a new execution, which I'll tell you what that is in a minute, and we pass it the arguments that the block was called with, as well as the block's original binding. And so a binding is the context in which the block was defined. We often talk about closures as being a function with some context. This binding is that context. And we can use it in eval or instance eval to run some code as if we were inside of the block. And this will become useful in a minute. We then instance eval the block on this new execution we've defined. So what's an execution? Execution is an instance of basic object. If you haven't seen basic object before, as of Ruby 1.9, it is the superclass of object, and it has almost no methods defined on it. So if you call basicObject.new.class, you actually get an error because it doesn't have a class method. It doesn't have respond to. All these things we take for granted. It's a blank slate to work with. So it gets past the arguments that the original block was called with, and also that block's binding. And then because we instance eval it on the previous slide, this method missing is going to be getting called for all of the names inside the block that we don't know about. So for most of the names, it'll get called, and we use instance eval on the binding to pull the original method out of the context in which the block was defined. And then we call that method with the arguments that were passed. But if the method that was called is underscore, we instead shift off an argument. So args here is going to be the number 1, perhaps. And so we can fill in the underscore with the arguments that were passed in, which is exactly what partial application is. So let's look at this again. We have this underscore method that builds a new partial application with the block it's given. The partial application has 2 proc called on it and returns a lambda that then builds a new execution, which will evaluate this block. When this block is getting evaluated on the execution, method missing is called with underscore, and this underscore method then returns the number 1 or 2 or 3. And when rand is called, it's reevaluated in this context. And so we run this in IRB, and we get 1, 2, and 3 plus some random numbers. Again, I think this is ugly and bad, but it's kind of cool that we can do this, and it's a testament to how flexible and powerful Ruby is. So let's move on to talking about Haskell for a little bit. Haskell is a very different language than Ruby, and I'm not going to go into that too much. But it has what's known as lazy evaluation, meaning that the result of some code that you write is not evaluated until its result is needed, even if you call that code. So let's see this in an example. This is the only Haskell I'm going to show you, I promise. It's not fun to look at. So we have this method railsconf, and we declare that it's going to take an argument of type IO network stream result response string, which you should just think of as a response from an HTTP request. And it returns something of type string. So we define the implementation of this method. It has the argument response, and is going to return the string, I'm lazy. We put this in a script. We define the main method to print out the result of calling this railsconf method with the result of this HTTP request. And so I ran this code on my laptop, and it printed out, I'm lazy. I turned off my Wi-Fi and ran it again, and it still printed out, I'm lazy. So either Haskell doesn't need a network connection to make HTTP requests, which would be really awesome, or there's something else going on, which is lazy evaluation. We never actually used the result of that HTTP request, so the request was never made. Let's contrast this with Ruby. We have the method railsconf, which takes in an HTTP response and returns, I'm not so lazy. We have a method to make an HTTP request given a URL, and then we, at the bottom, print out the result of making that request and passing it to railsconf. And of course, you run this code, it prints out, I'm not so lazy, you turn off your Wi-Fi, you run it, it errors. But we can define this thing called lazy, which will let us be lazy in the same sense that Haskell is. That the block passed to lazy will only be evaluated if the result from it is actually needed. And let's see how we can build this. 7 lines of code. We store the block, and again, this is a basic object. So whenever any method is called on it, method missing gets triggered. Method missing will evaluate the block once, and then send on the method that was called on it. And then in future calls of method missing, it'll just send along the method. And this is very similar to what Active Record does with associations. When you call blogposts.comments, it doesn't actually make a SQL query right then and there. When you call blogpost.comments.all, it executes the query and returns an array. And if you call blogpost.comments.class, it executes the SQL query, and the result you get is array, even though that comments class clearly can't be an array. It's doing something almost identical to this. So let's look at another example of this. We have this method 3 that lazily prints out the number 2 and returns 3. We run method 3 and assign its result to x. We print 1, and then we print x. And so this will actually print out 1, 2, 3. because of the lazy evaluation. So when we assign x to 3, x is actually going to be this lazy block. And then at the bottom, when we try to print x, the block runs printing 2 and then returning 3, which then gets printed by the last line. If you're paying close attention, you realize lazy could just be a decorator. So I promised you that I would talk about the good, the bad, and the crazy, but we haven't really seen anything crazy yet. So remember I said that Haskell applies this laziness everywhere, and we've just applied it to these specifically constructed blocks in Ruby. Well, we can loop over every class in Ruby and every method inside of those classes and redefine them to be lazily evaluated. And you have to make a couple of exceptions. You have to, like puts obviously can't work lazily. And also the methods we're using in here can't be lazy. But after you do this, you can actually write working programs where you do puts 1 + 1, and that plus is evaluated lazily, but you still get the result 2. And it's incredibly slow. But there are also some places this laziness technique could be useful. Not the full replacing everything, but just our blocks. So pretend we have a Rails app. This is funny that this is the first Rails code I've showed at Rails Conf, whatever. Our action gets some tweets from the Twitter API, and then our view loops over those tweets and prints out the author and the tweet. In Rails 3.1, they added something called streaming responses, meaning that it can actually start sending back the result of rendering your page before the page has fully been rendered. And this is incredibly useful because the things at the top of your page are often your CSS and JavaScript files that require extra requests to get. And so if you send back the first 2 kilobytes of your HTML, the browser can start fetching those JavaScript and CSS files before the rest of the pages even come down. The problem here is that even if we were using that technique, we have to wait for the controller action to finish, and hitting the Twitter API can take a long time. But we could wrap this request to Twitter in a lazy block. And you'll notice we didn't have to make any changes to the view, but now we can use the streaming response to render the top of the page, and then once it tries to render the tweets, it'll make the request. So, moral of the story is next time you hear your coworker say, I really wish we could use Java-style annotations right here, or tail call recursion would make this code so much cleaner. Realize that we can build these things into Ruby ourselves. Ruby is incredibly flexible, and I've just shown that we can bring in features from other programming languages into Ruby. It's often a really bad idea. There's often performance implications, but there's a number of places where it absolutely makes sense, and that's why Ruby is cool. I'm Michael Fairley. I work at 1000 Memories, and you can find me on GitHub and Twitter as Michael Fairley.